All right, let's talk about Amazon S3. We all know it's this massive, virtually limitless storage service, right? But have you ever noticed that sometimes it just feels slow? That's the big paradox we're diving into. We're going to figure out how to unlock its true speed and really supercharge your S3 performance. Let's do it.
And it's a really good question, isn't it? Because on one hand, S3 is designed to handle pretty much anything you can throw at it. But there's a world of difference between just handling the load and handling it fast. The secret, it turns out, isn't about S3's limits at all. It's all about how we approach it.
See that word right there, distributed. That is everything. You've got to stop thinking of S3 as like one giant hard drive up in the cloud. It's not. It's this massive, sprawling, distributed system. And getting your head around that idea, well, that's the key to making it fly.
Okay, so here's how we're going to break this down. First, we'll hit some fundamental habits. The basics you just got to get right. Then, we'll dive into two big goals, maximizing throughput for moving huge amounts of data and minimizing latency for those super quick responses. And we'll wrap it all up with the big one, the mental shift you need to make to really think at S3 scale.
All right, first things first, let's talk about the essential habits. These are kind of like the non-negotiables. Seriously, if you just get these right, you can avoid a ton of performance headaches before they even pop up. Okay, so these might seem basic, but trust me, they are crucial. 1, you got to measure your performance. If you don't measure it, how are you going to fix it? 2, keep your compute, like your EC2 instances, in the same AWS region as your S3 bucket. That's just a free win on network latency right there. And 3, and this is a big one, always use the latest AWS SDKs. They've got so many optimizations built right in, especially when it comes to handling this one particular error code.
The 503 error.
Oh yeah.
If you've ever pushed S3 really hard, chances are you've seen this pop up. And your first reaction is probably, oh no, something broke. But that's not what's happening. Not at all. This is where we need to change how we think. A 503 slowdown isn't really an error. It's more like a signal. It's S3 literally talking to you, saying, whoa, hold on a sec. You're going faster than I expected, but I'm scaling up right now to handle your request. It's not a failure, it's feedback.
So what's the right move when you see one? Simple. You just wait a beat, and then you try again. And you do this with something called exponential backoff, which just means you wait a little longer between each retry. But here's the best part. If you're using a modern AWS SDK, this is all handled for you automatically. It's already built in. You don't have to do a thing.
Okay, with those fundamentals out of the way, let's dive into our first big strategy, maximizing throughput. This is all about raw speed for huge amounts of data. Think big files, massive data sets. But first, we need to be really clear about the difference between throughput and our next topic, latency. Yeah, see, performance isn't just one thing. When we talk about throughput, we're talking about total bandwidth. It's like trying to fill a swimming pool with a giant fire hose. On the other hand, latency is all about getting a really fast response. That's more like a quick, snappy shot from a water pistol. So, are you running a huge query on a petabyte-scale data lake, or are you just trying to load an image for a social media feed? What you're trying to do completely changes the strategy.
And this is the absolute key. You have to stop thinking of S3 as a single endpoint. Here's an analogy I love. Think of S3 like a massive supermarket. If you try to send every single customer through one checkout lane, you're going to have a huge line, right? A bottleneck. But S3 isn't a supermarket with one checkout lane. It has, for all practical purposes, an infinite number of them. The trick is to open them all up.
So how do you open more lanes? You scale horizontally. Instead of making one single massive request, you break it up. You make lots and lots of smaller requests all at the same time over totally separate connections. And the wild part is, S3 puts no limit on how many connections you can make to your bucket. Go nuts!
A really concrete way to do this is with something called byte range fetches. So let's say you have a huge 100 gigabyte file. Instead of trying to download that whole thing in one shot, you tell S3, hey, give me the first 100 megs. And on another connection, give me the next 100 megs, and so on. You can do this thousands of times, all in parallel.
And this is brilliant for two reasons. First, your total or aggregate throughput goes way up because you're pulling data down through all those connections at once. But second, it makes your downloads way more resilient. If one of those little 100 meg chunks fails for some reason, who cares? You just have to retry that tiny piece, not the whole massive 100 gig file all over again. It's faster and safer.
Okay, so that's throughput, moving big stuff fast. Now let's flip the script and talk about latency. This is all about getting those quick, snappy responses.
This is what's absolutely critical for any kind of interactive application, where every single millisecond really matters to the user.
So here's the classic problem, right? You've got one file that's super popular. Maybe it's a viral image or the main JavaScript file for your web app. If you have millions of users all trying to grab that same file, and every single one of them has to make a round trip all the way back to your S3 bucket, yeah, that's not going to be fast.
The answer, of course, is caching. The idea is simple. You use a service like Amazon CloudFront to make copies of that popular file and stick them in data centers all over the world. We call these edge locations. So now, when a user in, say, Tokyo asks for the file, they don't have to go all the way to your bucket in Virginia. They just get the copy that's right there in Tokyo. It's way, way closer.
And the difference this makes is, well, it's not small. We are talking orders of magnitude faster. The latency just plummets. We're talking about going from a few hundred milliseconds down to just a few. And that's the difference between an app that feels instant and one that feels sluggish and frustrating.
Okay, here are 2 more pro tips for killing latency. First, be aggressive with your retries. If a request seems slow, don't just sit there and wait for it. Cancel it and immediately retry on a brand new connection. A lot of the time, that new connection will find a faster path through the network. And second, if you're transferring data over really long distances, like from your laptop in Europe to a bucket in the US, use S3 transfer acceleration. It basically gives your data a fast lane on AWS's private global network, instead of sending it over the messy public internet.
So, we've gone through a bunch of different tactics, right? For throughput, for latency, but they all point back to one single powerful idea. If you remember nothing else from this, remember this. This quote really just says it all perfectly. When you build high-performance applications, think of Amazon S3 as a very large distributed system, not as a single network endpoint. You have to stop seeing it as one place you send requests to. It's not a single door, it's a wall with a million doors. Your job is to open as many of them as you can at the same time.
And that's the bottom line. It doesn't matter if you're optimizing for throughput or latency, the answer is always the same. You have to parallelize your requests. You have to distribute them. Don't send one giant request. Send 100, send 1,000 small ones instead.
Once you make that mental shift, from seeing a single-lane road to seeing a massive superhighway, you completely change what you can build. All that performance is just sitting there waiting for you to unlock it. So now that you know how to think at S3 scale, what are you going to build?